Right now, somewhere in our galaxy, a black hole is moving silently through space. No light, no warning. And scientists confirm it could be heading toward us. Here is what happens if it gets close enough. A rogue black hole does not announce itself with light. It slips through the galaxy in perfect darkness, revealing its presence only through the warping of gravity. Astronomers call this astrometry, the science of measuring tiny motions in the positions of stars and planets. If a black hole entered the outer reaches of our solar system, for example at a distance of 1,000 astronomical units, the subtle tug on the sun would take decades to become measurable. At that range, the warning time stretches thin, but still offers years to act. As the black hole draws closer, the clock accelerates. At 100 astronomical units, the gravitational fingerprints become obvious, but now there may be only months to react. By the time it breaches 10 astronomical units, the warning collapses to mere weeks or days. No visible light betrays its approach. Only the shifting orbits of distant planets, or a sudden, unexplained wobble in the sun's path, whisper that something enormous is coming. The margin for early detection narrows with every astronomical unit, and the solar system's fragile order hangs on the edge of the unknown. Neptune and Uranus stand as the first sentinels to feel the black hole's approach. As the intruder closes to the outer planetary region, its gravity reaches across billions of kilometers, nudging the orbits of the ice giants. High-precision simulations show that even a single pass by a black hole with 10 solar masses at just 12 astronomical units can shift Neptune's semi-major axis by 0.04 astronomical units and excite its orbit to an eccentricity of 0.12. These numbers might sound small, but for a planet, they are seismic. The change ripples inward, destabilizing the delicate resonance that locks Uranus and Neptune into their current dance. Secular propagation carries the disturbance onward, setting the stage for deeper chaos. As Professor Konstantin Batygin puts it, a tiny gravitational impulse to Neptune can, over time, unravel the entire solar system's order. The first imbalance has begun. The outer giants, once stable, now reel under the invisible hand of a passing black hole. The asteroid belt, once a stable ring of ancient debris between Mars and Jupiter, becomes a battlefield in the wake of a black hole's gravitational assault. As the outer planets reel, the shockwave of orbital chaos sweeps inward. The NU-6 resonance, a hidden gravitational boundary set by Saturn's orbit, begins to drift. This subtle migration acts like a cosmic broom, stirring the belt's rocky fragments into unstable orbits. Within a few million years, the average eccentricity of asteroids doubles or even triples. The number of potential Earth-crossing bodies surges, with impact rates climbing 2 to 3 times above normal. Simulations show that as the resonance sweeps outward by just 0.1 astronomical unit, vast numbers of kilometer-scale rocks are nudged onto lethal trajectories. What was once a distant, silent zone now becomes the source of a relentless meteor storm. The path from outer solar system instability to inner planet danger is set, not by direct collision, but by the invisible hand of gravity, turning the asteroid belt into a launching ground for destruction. Earth's surface would not escape the black hole's grasp. As the intruder's gravity sweeps inward, tidal forces begin to stretch the planet itself. Calculations show that a 10 solar mass black hole passing within a few astronomical units could generate tidal accelerations up to 3.5 times 10 to the minus 5 meters per second squared, nearly 30 times greater than the moon's pull on our oceans. The ground would flex by meters, not centimeters. Seismic stress would surge, with fault lines everywhere pushed closer to the breaking point. Even a modest stress increase of 0.01 to 0.1 megapascals could tip critically loaded faults, triggering earthquakes in rapid succession. Volcanoes respond to pressure from below, and the odds of eruption climb as magma chambers feel the squeeze and release of these passing tides. Dr. Rosalie Lopes, a planetary volcanologist, warns that subtle changes in tidal forces can tip a volcano from dormant to erupting. On a planetary scale, the effect is multiplied. Under these conditions, continents would shudder, mountain ranges could fracture, and the sky would darken with ash. The planet's surface, once stable, becomes a landscape of chaos as the black hole's invisible hand tightens its grip. Earth's fate hangs on a razor's edge determined by distance and mass. The decisive line is the Roche limit, the point where tidal forces from a black hole exceed the planet's own gravity. For a 10 solar mass black hole, the event horizon is just 30 kilometers across, but its influence reaches far beyond. If Earth stays outside the Roche limit, it might survive, battered but whole. Closer, the planet is torn apart, its crust and mantle stretched into a stream of debris. There is a third, grimmer possibility: a direct plunge past the event horizon where not even light can escape. The outcome depends on the trajectory, the black hole's mass, and a handful of cosmic kilometers. These thresholds draw the final boundary between survival, destruction, or oblivion. Millions of rogue black holes drift through the Milky Way, silent, cold, and nearly impossible to see. These objects do not shine. Their presence is betrayed only by the way they bend the light of distant stars. Astronomers have confirmed the existence of these wanderers using gravitational microlensing, where the gravity of a black hole magnifies the light of a background star for weeks or months. Dr. Kailash Sahu, who led the team that confirmed the first isolated black hole, says that we now know there are many more of these invisible objects than we ever imagined. Population studies estimate between 1 and 10 million of these dark bodies roam our galaxy, each a potential threat moving unseen. The universe hides far more danger than its calm appearance suggests. The universe is not as safe as it looks from here. The next time you look up at a clear night sky, remember, something massive and invisible may already be moving through it. Subscribe to Quantum Lens. The universe has more secrets than you can imagine.